Hello everyone, welcome to another AMC 8 video. Today we'll go through the 2023 exam of AMC 8. In this video, I'll walk you through all the problems, breaking them down step by step and teaching you all the things that you need to know. I'll also share my best tips and strategies to solve the problems fast and get them done efficiently. So if you're new here, consider subscribing and let's get right into the video. Okay, so in this problem, we have to find the value of this expression. This can simply be done by using the order of operations, for which we can use PEMDAS. PEMDAS tells us the order in which we should apply the operations. So first off comes the parentheses. So we'll do whatever is inside these parentheses first. Within those parentheses, we have to do, again, multiplication first, and then comes addition. So within the first one, we do 8 times 4, which is 32. Plus 2 is 34. That's the first parentheses. And then in the next one, we have to do 4 times 2 first. So that's going to be 8. 8 plus 8 is 16. And 34 minus 16 is 18. Therefore, the answer is D. So in this problem, we are folding a square piece of paper. So first, it looks like we folded it over this line. And then we fold it over this line. So this is going to be the bottom right corner. And when you cut it like this, it's going to cut the inside regions of the square piece of paper symmetrically. So we can clearly see it's going to be answer choice E, but you can also get this answer by elimination. So yeah. Okay, so in this problem, they want us to find something called wind chill, which is just air temperature minus 0.7 times wind speed. And we can clearly see they've given us the temperature here and the wind speed, which is 18. So all we have to do is just do this calculation and we're done. So 18 times 7 is 56, and then 12. So since it was 0.7, therefore the answer is going to be 12.6. Now we just need to do 36 minus 12.6. Since 36 minus 12 is 24, we take 0.6 off and we get 23.4. So the closest answer is going to be B. So that's our answer. So in this problem, they are just writing out numbers in order from 1 onwards in this spiral pattern. And what they want us to do is find out how many of the numbers that appear on these gray squares are prime. So let's just count it out and let's see what we get on those boxes. So we have 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 is a prime. 20, 21, 22, 23. 23 is also a prime. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Now 39 is not a prime. It's a multiple of 3. So we cross that out. 40, 41, 42, 43, 44, 45, 46, 47 is a prime. So out of these 4 boxes, 3 of those were prime, so the answer is D. Okay, so in this problem, there is a lake which has 250 trout. Now, a biologist catches a sample of 180 fish in total, so that's the fish. And out of those, 30 of them were the trout fish. Now they're saying if the ratio of the total number of fish, the ratio of the trout to the total number of fish, so this ratio is the same for the lake and the sample, then how many fish are there going to be in the lake? So let's see. So we can just mark this as X. So the ratio of the trout to fish in the lake is going to be 250 over X. In the sample, it's going to be 30 over 180. So if you want to find X, well, let's simplify first. We can cancel the zeros. 3 times 1, 3 times 6. So when you cross multiply, you get X equals 250 times 6. So X is going to be 1500. So our answer is B. Okay, so in this problem, they want us to place the digits 2, 0, 2, 3 in these 4 boxes and obtain the maximum possible value of the expression. Now, we can only use one digit once. That's kind of assumed here. So since we have a 0 here and we can't place a 0 in the base, right, because that will make the whole expression 0. So therefore, the 0 must go in one of these. Now, anything raised to power 0 is 1. So we want this number to be the smallest possible. So let's make this a 2. So this will become 2 raised to power 0. That's 1. Now here we have two options. Either we can do 2 raised to power 3, which gives us 8, or 3 raised to power 2, which gives us 9. Of course, the second option gives us a bigger value. So we'll place a 3 here and a 2 here, so it will become 9 times 1, which is 9, and that's the maximum possible value we can have here. So the answer is C. Okay, so in this problem, they've given us a coordinate grid and they've given us a few points and a rectangle. So the question is, they want to know how many points on the rectangle lie on one of these lines at least. So they just want to see how many points do these lines cut the rectangle at. So we can do that really easily if we just continue the lines and see where it intersects the rectangle. Now this line goes 3 across and 1 up. So if we just continue this pattern, we will be able to see exactly where it cuts the rectangle. So this line AB cuts the rectangle at this point right here. Okay, let's continue the line CD. So CD is going 1 down and 2 across. So if we keep going just like that, we will see that it barely misses the rectangle. So it's going to pass like this through these 2 points, and it's not going to cut the rectangle. So out of these 2 lines, we only have 1 point of intersection with the rectangle. So the answer is going to be B. Okay, so this is a very interesting problem. There are 4 players who are playing against each other, and they play against each other twice. So every person plays against the other 3 twice, so they're going to have 6 games in total. So you can think of these as rounds. Okay, so again, in every round, there are 2 games, and if you see, there are only 2 possibilities, right? You can either win or you can lose, right? So now just think about this. If you have a game, one person has to win and the other one has to lose. That means every column here should have 2 1s and 2 0s, because if you have 2 games, there are going to be 2 winners and 2 losers. And using that, we can easily figure out what all of these question marks are going to be. So let's see. So we have 1 1 0, so this is going to be 0. We have 1 0 1, again 2 1s, so this is going to be 0 again. We have 2 1s, again 0. We have 2 0s, so this is going to be 1. We have 2 1s, so this is going to be 0. And we have 2 0s, so this is going to be 1. So 0 0 0 1 0 1, that is going to be answer choice A. So in this problem, they have given us a graph which shows us the elevation of this person against time, and they want us to find out how much time they spend between the elevation of 4 and 7 meters. This is very easy. All you have to do is just mark the levels of elevation that they're asking for. So this is the 4 meter elevation mark, and this is the 7 meter elevation mark. Now let's see how much time does she spend in between them. So she spends this time between them, and this is going to be 2 to 4, so that's 2 seconds. Okay, then she spends this time between them, so it's going to be from 6 to 10, that's 4 seconds. And then he also spends this time between them, so it's 12 to 14, so that's another 2 seconds. So 4, 2, and 2, that's going to be 8, so the answer is B. So in this problem, Harold has a pie. Well, we can think of the pie as one whole. Okay, so Harold came and ate 1/4 of the pie. Now, how much is left behind after you eat 1/4? Well, 1/4 1 minus 1/4 is 3/4. So 3/4 is left behind. Okay, now Moose comes by and eats 1/3 of what was left behind. So let's see, they ate 1/3 of 3/4, that is 1/4. So now how much is left behind? Well, out of 3/4 we had before, we subtract the 1/4 and we have 2/4, which is 1/2. So 1/2 is left behind now. Okay, now after that a porcupine comes by and eats 1/3 of what was left behind. So 1/3 of 1/2 is going to be 1/6. That's what the porcupine ate. Now how much is left behind after that? Well, 1/2 was left before. We subtract the 1/6 and what do we get? So we can make them the same denominator. It's going to be 3 minus 1/6. That's 2/6, which is 1/3. So the answer is D. Okay, so this is a very interesting problem. We have the Mars rover, which is traveling this many miles in 6.5 months, and they want us to find the average speed. Well, all we need to know is the formula for average speed. And average speed is total distance over total time. So what is the total distance? Well, we know it's gonna be, let's approximate that as 300 million miles. Again, we can see that the answer choices are very far apart. So this small approximation is not going to make much of a difference, but it's going to make our calculations way easier. So this is in miles, that's good. They want the answer in miles per hour. So we need the time to be in hours, but it's given in months. So let's convert that into hours. Let's see. So we have 6.5 months. Now let's convert that into days first. So 1 month, so let's put months here, days here. So 1 month has 30 days. That cancels out the months. What is 6.5 times 3? Let's take a look. That's gonna be 19. So 6.5 times 30 is gonna be 195 days. Well, I can approximate that as 200 days. Again, we are approximating. 200 is a very nice number, so let's take that as 200 days. Now each day has 24 hours, so let me multiply that by 25. Again, I'm going to approximate 24 as 25. This is not going to make much of a difference, so 200 times 25 is going to give us 5,000. So we have 5,000 hours approximately, and you see these 3 zeros will cancel out with these 3 zeros, and I can do 5 times 1 and 5 times 6. So we have a 6 and 1, 2, 3, 4 zeros. That gives us 60,000. So the answer is C. Okay, so in this problem they want us to find the area of this shaded region as a fraction of the area of the large white circle. So let's first of all find these shaded areas. The simplest way to find this area, well, again, let's assume that this one box is 1 unit long. That's, again, gonna make our calculations very simple. It doesn't actually really matter what the actual radius is. So let's see, so taking one box as 1 unit long, let's see, this circle right here is gonna have a radius of 2 units. So that's gonna be pi 2 squared, so that's 4 pi. That's the area of this circle. Now to find the shaded region, we have to subtract the area of these 2 small white circles. Well, they have a radius of 1, so they are each gonna have an area of pi 1 squared, so that's pi and pi. When we subtract that from 4 pi, that's gonna give us a total of 2 pi. So that's this shaded area, that's 2 pi. Now what's the other shaded region we have? It's the area of these 3 circles. These circles have a radius of 1/2, so the area would be pi 1/2 squared, which is going to be pi by 4. Since there are 3 of them, we can multiply this by 3 and we get 3 pi by 4. Now the total shaded area is going to be, well, 3 pi by 4 plus 2 pi. Well, let's make them have the same denominator, and that's going to make it 3 plus 4, so that's going to be 11 pi over 4. Now that's not the answer. Thank God they didn't give 11 over 4 here, because that was going to throw us off. But we still have to find the area of the largest white circle, which has a radius of 3. So that is going to be pi 3 squared, which is 9 pi. So let's do 11 pi over 4 divided by 9 pi. Well, that's the same as multiplying by 1 over 9 pi. Again, if you remember from your math classes, keep, change, flip, right? Anyways, so we cancel out the pi and the fraction becomes 11 over 36. So the answer is gonna be B. Okay, so for word problems, you wanna start by reading the question first so that you know what you're really looking for. So they want us to find out how long the race is from start to finish. So you know what they want us to find? Let's define that as the variable. So we're gonna call this full length as X. Okay, now they said there are 7 water stations spaced evenly. Okay, so if on a straight line you put 7 stations, so 1, 2, 3, 4, 5, 6, 7, you're gonna break it into 8 equal parts, right? 1, 2, 3, 4, 5, 6, 7, 8. So if the total distance is X, that means the distance between each of these gaps is gonna be X by 8. Okay, so that's for water stations. Now we have 2 repair stations as well. So again, on a straight line, if you put 2 repair stations, it's gonna break it down to 3 equal parts. So if the total distance is X, then each of these gaps is X by 3. So now that we have that information, let's see what else have they told us. So they told us that the third water station, well, let's see, the third water station is this one. It's gonna be 1, 2, 3. It's gonna be at 3x by 8 mark, right? If we take this as the 0. So the distance from the start to the third water station is 3x by 8. And the first repair station is, of course, at x by 3. So they said the third water station, which is 3x by 8, is located, means equal to 2 miles after the first repair station. So the first repair station is x by 3 and it's located 2 miles after that. So that means 3x by 8 is x over 3 plus 2. That's a simple algebra equation that we have to solve and we will get the answer. So first off, let's quickly make them the same denominator. I'm going to multiply by 3. So that's going to make it 3x over 8 equals x plus 6 over 3. So I'm going to cross multiply and I'll get 9x equals, so 8 times x is 8x and 8 times 6 is 48. I subtract 8x from both sides and I straight up get x equals 48. So that means the total length of the race was 48 miles. So the answer is D. Okay, so in this problem we have a person, Nicholas, who is planning to send a package to his friend who is a stamp collector. Well, for that reason, he wants to put as many stamps as he can on the package. So he has 5 cent, 10 cent, and 25 cent stamps. He has 20 of each of them, and he wants to make a postage of $7.10 with the maximum number of stamps he can use. So, well, of course, if we want to maximize the number of stamps, we should use as many of the smaller amount stamps as possible so that we can have, a lot of them. So let's use first off all of the 5 cent ones. So 5 cent times 20 is going to give us 100 cents, and 100 cents is $1. So that's just going to make $1. We still have a lot left. So let's use all of the 10 cent stamps as well. So 10 times 20 is 200. 200 cents is $2. Well, we still have a lot of room. So let's use all of the 25 cent stamps as well. So 25 times 20, well, that's going to give us 500. Well, 500 cents is $5. Well, now that's over the limit. So that's going to be, if you use all these stamps that he has, that's going to make 1 plus 2 plus 5. That's going to make $8. Now that's too much. We have to take some off. So of course we want to take the bigger stamps off so that we don't reduce the total number by much. So right now we have 60 stamps and they total $8. Now if we remove 2 of the 25-cent stamps, it's going to be $7.50, still over. So let's remove 3 of them. So if we remove 3 of those stamps, we're going to get to $7.25. Okay, now if we remove another 25-cent stamps, we're going to go under, so that's not good. So let's now remove 10-cent stamp, and we can remove only one of those, because again, if you remove 2 of those, we're going to go under, so that's going to make it $7.15, and then we have to remove a 5-cent stamp, and that's going to make it $7.10. So we removed 3 25-cents, 1 10-cent, and 1 5-cent. In total, we removed 5 stamps. So we were able to make that amount with a total of 55 stamps, and that's the maximum answer that we have here. That means we are guaranteed to have gotten the right answer. So the answer is E. Okay, so in this problem, this person, Visham, walks to school each day. The total distance he covers is half a mile, which is consisting of 10 blocks of equal length. That means one block is 0.5 divided by 10, which is 0.05 miles, right? The total is 0.5, 10 blocks, so 0.5 divided by 10 is 0.05. Now, he does that in 1 minute. That means he will cover the total 10 blocks in how many minutes? He'll cover that in 1 times 10, which is 10 minutes. Okay, so that's the total amount of time he takes from the starting point to the school. Now, on this particular day, he was walking normally until this point. So he got there in 5 minutes. And then there was a blockade. So he had to take a detour. But they want us to find out what his new speed should be so that he gets to the school at the usual time. That means the total amount of time it should take is still going to be 10 minutes. So we already walked for 5 minutes, so the rest of the journey should take 5 minutes as well. So let's use the speed formula. So speed is distance over time. The time we need to do is 5 minutes, okay? And the distance that he is left with is 8 blocks. So 8 times 0.05, let's do that. 0.05 times 8, well, that's gonna be 0.4. So he has to do 0.4 blocks, 0.4 miles in 5 minutes. Now, that's actually not the answer because they want the answer in miles per hours. So that's why you won't see this kind of an answer here. So let's convert that into hours. So we have 0.4 miles, which we can write as actually 4 over 10. 4 over 10 divided by 5, which is the same as times 1 over 5 minutes. And let's convert the minutes into hours. So I'm going to multiply by minutes, divide by hours. The minutes going to cancel out. Let's balance this. 60 minutes is 1 hour. So let's just simplify. So let's see. This is going to make it a 6. So we have 4 times 6, which is 24 over 5. Now, what is 24 over 5? Well, we can just do long division. We don't have to overthink this. So 24 divided by 5. Well, 5 times 4 is 20. You subtract, you get a 4. You could put a decimal. You can put a 0 here. 5 times 8 is 40. So the answer is going to be 4.8. So the answer is D. Okay, so this seems like a very hard problem, but it's actually very easy if you catch on to the right idea. So we have to find the number of P's, Q's, and R's that appear in this 20 by 20 pattern, 20 by 20 table. Now, the wrong approach is, of course, trying to draw the 20 by 20 table and writing all the letters, which is doable, but it's going to take a lot of time, and you don't have that time in the AMC. So let's come up with a smarter approach. Again, remember, if something takes too long, that's, again, definitely not the right approach. That means there must be a faster way. So let's take a look at this. Well, you can observe that uh, along the diagonals we have the same letters, right? And there is a very clear pattern, right? So we start with P, and there is one P, right? And then we have Q, where we have two Qs. Then we have R, we have three R's, and then it keeps going. Then we have four P's, five Q's, six R's, and it's gonna keep going, but until when? So it's gonna keep going until 20, because when you have 20 by 20 block, yeah, of course, then we're gonna have a diagonal made up of 20 boxes, right? So then after that, it's gonna start decreasing. So we have, actually, let's write it down like this: PQ and R. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me adjust that. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now after that, it's going to start decreasing again. So 19, 18, 17, 16. Okay, it's going to be long. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Now, first off, what we can observe is that P and R are just the reflection of each other. Okay, P is just R in reverse. Okay, so they're going to be the same. Let's see. So that will rule out answer choice A. That will rule out answer choice B. That will rule out answer choice E. So the only answer choice we're left with is C and D. So if we just figure out one of these numbers, we should be good enough. So let's actually figure out what P is, and that should be good. So let's see. We can have a 10. Okay, let's make tens. That's a really nice way to count. And then 3, 7 and 13, that's another 20. Okay, so let's cross that out, or maybe let's circle that. Okay, and then 16 and 4, that's another 20. 19 and 1, well, another 20. Then let's do 15, 9 and 6. That's gonna make a 30. So we are using tallying, by the way, to keep track. Now 18 and 12, that's gonna make another 30, and 3. So it's gonna be 130 plus 3, so 133. So the answer is gonna be C. We don't have to calculate what Q is, and of course R is gonna be the same. So the answer is C. Okay, so in this problem, we have this piece of paper that we have to fold to make this octahedron. Now, this may seem like a really intimidating problem, but you don't really need crazy visualization skills to be able to do that. We will just keep track of the edges and some points, and we will be able to do this very easily. So fortunately, again, they left the label Q, and that will actually guide us into figuring out what all the numbers are, and eventually figure out what number comes in this place. So first off, let's see. Above Q, the point above Q, let's mark this with the orange dot. So that must be this one right here, right? Directly above Q. Yeah? So that must be the orange dot. Now let me mark the right side of orange to this dot as green. So this must be the green edge. And let me mark the left one with blue. So this must be the blue edge, right? Now Q shares the blue edge with 6. So then this must be 6. Now let me mark the other edge that 6 has, that converges to or connects to the orange dot. Well, that let's say that's green. Sorry, that's pink. So then this must be the pink edge. Now 6 shares the pink edge with one number, which is 7. So this right here must be 7. Now let's take a look at the third edge of 6. let me label that, let me mark that orange. Okay, so the third edge of 6 is orange. It must be this one. Now 6 shares this orange edge with 5, so this must be 5. Now something very, very interesting happens when you look at the other two edges of 5. Let me mark that with pink. So the other two edges of 5 converge at this dot. Let me mark that with a pink. So that's the pink dot, and this pink dot is shared by 4 numbers: 5, 4, 3, and 2, right? So the only number that does not share that dot is 1. So 5, 4, 3, and 2 must be around this pink dot, so they must be here, here, and here. The only one that does not share it is 1, so that must be what comes in this space. So our answer is A. So in this problem we have a grasshopper that sits on a long line of lily pads, and it can make 5 jumps to the right or 3 jumps to the left, and we need to get to the lily pad number 2023. Now let's think of it as a number line, okay? And each of the integers are just lily pads, and we are adding 5 or we are subtracting 3, and we need to get to 2023 in the minimum number of steps. So first of all, again, we should add as many 5s as possible to get as close as possible to 2023. So we can do that by getting to 2025. And how many steps would that take? Well, 5 times 4 is 20, so 5 times 400 is 2,000. We need to go, 5 more. So we will go 5 more to the right, 5 more steps of 5 to the right, and that will give us 2025. Now we need to subtract 2 using multiples of 5 and multiples of 3. How do we do that? Well, let's list down the multiples of 5. So we have 5, 10, 15, and then we have multiples of 3. So we have 3, 6, 9, 12. So we want a multiple of 5 that is 2 less than a multiple of 3. And that is going to be 10 and 12, right? Because if we add 10 and subtract 12, we're going to end up subtracting 2 overall. So we add 2 more steps of 5, and then we subtract 4, 3 times 4, so we make the 4 jumps of 3s backwards to the left, and that will end up giving us, so this will be 2035 minus 12. Minus 12 is going to give us 2023. How many jumps did it take in total? So 4 or 5 jumps initially, then 2 more jumps of 5, and then 4 jumps of 3s to the left. So that gives us a total of 5, 6, 7, 8, 9, 10, 11, a total of 411. So the answer is D. Okay, so in this problem we have an equilateral triangle. Well, equilateral triangle is a triangle with all sides equal and all angles equal. So that means they're all 60. Okay, so a bigger equilateral triangle and a smaller equilateral triangle, and then they just break down the region between them with 3 straight lines, and that gives us these 3 trapezoids, right? A trapezoid is a shape with 2 parallel sides. So this is a trapezoid. Now, what do they want? They want us to find the ratio of the area of the inner trapezoid to the area of the inner triangle. This is a ratio problem, and let me tell you a trick. In ratio problems, it actually doesn't really matter what actual values you use. What matters is the relationship between the terms that you're finding the ratio of. So here, you can take the side length of the outer triangle to be S, because they didn't really tell us what that is. But you can even take it to be 1 or 3 or whatever you want, any number you want that can make your calculation easier, because at the end of the day what matters is the ratio. So I'm going to take the outside length to be 3. So now the inner triangle will have a side length of 2/3 of the outer one. So 2/3 of 3 is just going to be 2. Now, why did I do that? Because that makes it super easy for me to do the calculations, since I don't have to deal with fractions anymore. Anyways, now how do I find the areas of an equilateral triangle? Now, if you know a bit about equilateral triangles, you'll be able to do this problem very, very fast. Let's see. So if the side length was S, then how do we find the area? Well, area is half base times height, right? So the base here we can take to be the side S, but what is this height? What is this height of that equilateral triangle? Well, if you drop a perpendicular from that point, it splits the triangle into two triangles, and this is a right angle. So this turns out to be a 30, 60, 90 triangle. Okay, and 30, 60, 90 triangle, if the hypotenuse is S, well, we know this side, well, it's half of S, so it's S over 2. And using Pythagorean theorem, you can figure out really easily this is going to be S over 2 square root of 3. Okay, so that means the height of an equilateral triangle with a side length of S is S over 2 square root of 3. Now, we have our formula for the area of an equilateral triangle. And again, of course, since you would already know this on the exam day, you'll be able to just use it directly and find the answer. So what is the area of the outer triangle? Well, we took the side length to be 3, so that's going to be 3 squared is 9, so 9 square root of 3 over 4. That's the area of the outer equilateral triangle. And then the area of the inner equilateral triangle is going to be 2 squared root of 3 over 4. So that's going to be 4 square root of 3 over 4. Now, we need to subtract them. So let's subtract them, and what do we get? We end up having 5 square root of 3 over 4. And then when we divide that into 3 parts, so we'll just divide that by 3, and we end up getting 5 square root of 3 over 12. That's the area of one trapezoid. Now, we need to take the ratio of the trapezoid, the area of the trapezoid, which is 5 square root of 3 over 12, with the area of the inner equilateral triangle, which is 4 square root of 3 over 4. Now, 4 cancels out with 4, and then actually it might be easier to see things if I write it like this. So 4 square root of 3 over 4. 4 cancels out with 4. Square root of 3 cancels out with square root of 3. And we're just left with 5 over 12, which is the same as 5 ratio 12. So our answer is C. Now, if you knew only this one thing about equilateral triangles, you could have done this problem in like less than 2 minutes. Okay, so yeah, that's how you do it. Okay, so in this problem, we have this list of numbers 3, 8, 11, and 28. And they said that they insert 2 integers into this list, and that doubles its range. Well, we'll talk about that later. But the mode and the median remain unchanged. So what is mode? Mode is the most frequent term. So the most frequent term right now is 3. That means there is no other repetition that can happen. No number can have 2 copies because that is going to change the mode. And the median right now, what is that? The median is the middle value when you arrange it in ascending order, and that's going to be 8. So if you add 2 more numbers and the median remains unchanged, well, that means that one number is to the right of 8 and one number is to the left of 8, right? Okay, now they want to find those 2 numbers such that their sum is the maximum possible. Okay, so first off, let's see what the range of this list is right now. So it's gonna be 28 minus 3, which is 25. That's the range right now, and they want to double the range, so they want the range to be 50. Now, how do we make it 50? Well, it can be 50 if you do 53 minus 3, because the smallest number is going to be 3. So one of the numbers is going to be 53, of course, so that the range doubles. but then the other one has to be here. So what is the maximum possible number we can have to the left side of 8? Well, that has to be 7. So 7 plus 53 gives us 60, and that is the maximum possible we can have. So that's the answer choice D. Okay, so here Alina writes numbers from 1 to 9 on separate cards, one number per card. She wishes to divide the cards into 3 groups of 3 cards, okay, so that the sum of the numbers in each group will be the same. In how many ways can this be done? So the first thing we should figure out is what is going to be the sum of that group, and that is going to be really interesting to find, because the total sum of the 3 groups is going to be the same as the sum of all 9 numbers. So what is the sum of 9 numbers? 1, 2, 3, 4, all the way up to 9. Well, actually let me write that whole thing. So 5, 6, 7, 8, 9, and I'll show you a trick here. So you can add them really easily if you just realize that the first and the last, they add up to 10. Second and second last also add up to 10. Third and third last, fourth and fourth last. So all these pairs add up to 10. So that's 4 pairs, that's 40. Plus the middle one, that's 5. So the sum of these nine numbers is 45. Of course, you could have done that very easily by using that formula for the sum of n numbers, n times n plus 1 divided by 2. But just for those who are not familiar with it. Anyways, so sum of the 3 groups is going to be 45. Now, what does that mean? What is the sum of cards in each group? Well, each group will have then 45 divided by 3, so 15. So we have 3 groups that add up to a total of 15. Okay. Now, let's see, how can this be done? Well, 9 has to go somewhere, so let's say 9 is here. Now, can 8 go in the same group? Well, no, not really, because 8 plus 9 is 17, so that, is over the limit. So 8 has to be in a different group than 9, okay? Then can 7 and 8 can go in the same group? Well, 7 plus 8 is 15. Well, we still need another card, so 7 and 8 also can't go together. So 7, 8, 9 must be in 3 separate groups, okay? So now we know that. Well, what is left behind now? So we have 1, 2, 3, 4, 5, 6. Okay, let's just go one by one. Let's say we have 6 here. So 9 and 6 will add up to 15. Well, that's not possible. So 6 can't be here. Then what about 5? So 9 and 5 is 14. So yeah, that's one possibility, that we can have 1 and 5 here with 9. Okay. Can we have anything else? Well, these two have to add up to 6. So 5 and 1, and the other possibility would be 4 and 2. Those are the only 2 possibilities we can have with 9, because we can't really make 6 any other way. So we will consider them separately. Let's just take a look at the case where it's 5 and 1. Well, if this is 5 and 1, what do these have to add up to? Well, it's 8, so these have to add up to 7. 5 and 1 are already taken. There's only one way to make a 7 now, and that is using 4 and 3. So these two must be 4 and 3 in whatever order, and then the last two, must be 2 and 6. So we have one possibility. This is one possible scenario that we have. Okay. Now the other scenario. Well, let's see. Again, 7, 8, 9. We know these two have to add up to 6. Let's say that instead of 5 and 1, we this time take 4 and 2. So if these are 4 and 2, then again these have to add up to 7. The only way to make 7 now with the remaining numbers is 6 and 1. Okay, and then of course 5 and 3 will come here. Okay, so these are the 2 possible ways in which this can be done, and there are no other ways, because again we counted systematically. No other way to group them in 15s So yeah, the answer would be C. Okay, so in this problem we have a sequence of positive integers, and each term after the second is the product of the previous two terms. And they're telling us that the sixth term is 4,000. So let's do it like this. 1, 2, 3, 4, 5, 6. And this is supposed to be 4,000. So how do we use this information that, each term after the second one is a product of the previous two terms? Well, we have to, write an expression for that. So how do we do it? Let's say that the first one is A and the second one is B. We need the first two. But after that, the third one we know. The third one is going to be the product of the previous two. So it's going to be A times B. Okay? And the fourth one is going to be the product of the second and the third one, which is going to be A times B squared. And then the one after that is going to be the product of the previous two, so that's going to be A squared B cubed. And then the sixth term is going to be the product of the fourth and the fifth one, which is going to be A cubed B to the 5. So just like that, we now know that 4,000 is supposed to be A cubed B to the 5. But how do we now figure out A and B? Well, a really nice trick you can use is do the prime factorization of 4,000. Let's see what we get. So 4,000 is just 4 times 1,000. 1,000 is 10 cubed, which is just 2 cubed and 5 cubed. And 4 is just 2 times 2. So in essence, 4,000 is just 2 to the 5 and 5 to the 3. Now, by using direct comparison, we can clearly see that A is supposed to be 5 and B is supposed to be 2. And just like that, we now know that the first term is going to be 2. So even though it's problem 22, it's supposed to be really hard, by using the right method, the right approach, you can get it done very easily. Okay, so in this problem we have a 3x3 grid which we have to fill with these 4 types of tiles. Now, since we can't change their orientation, therefore these are 4 unique tiles. Okay, now they want us to find the probability that the tiling that we do contains a diamond like this in a 2x2 box. And they gave us an example of this as well. So since this is a probability problem, we will use the probability formula. By the way, every probability problem can be solved with this formula. So whenever you have a probability problem, just write down the formula for probability, which is the number of successful possibilities over the number of total possibilities. Now, let's first of all figure out what are the total number of patterns that we can make. Now, for each tile, we have 4 possible choices, right? And since they are all independent, therefore we will multiply them together to find the total number of possibilities. So that's going to be 4 to the power of 9. That's the total number of possibilities that we have. So total is 4 to the 9. Okay, now what is the successful number of possibilities? Well, what is success? Success is when we have this shape within a 2x2. So let's say that that shape occurs in this bottom 2x2. Then this has to be, a fixed pattern. And for this to happen, we have to exactly use these tiles. Okay, so there's no choice there. But the other 5 can be anything. So we have 4, 4, 4, 4, 4. So 4 to the power of 5 possibilities if we have this diamond in the bottom right. But we can actually have it in 4 different places. We can have it here, or we can have it here, bottom left, or top right. So we have, in fact, 4 possible places that this diamond can be in, and each of those have 4 to the 5 possibilities. So we'll just multiply this by 4. That will give us 4 to the 6 successful possibilities over 4 to the 9 total possibilities. We divide that out, and that would give us 1 over 4 to the 3rd, which is 1 over 64. So the answer is C. Okay, so in this problem, we have two identical triangles, two copies of the same triangle ABC, and ABC is an isosceles triangle. So let's see. They told us that AB and BC are the side lengths that are equal, and they just drew lines parallel to the base of this triangle. Now, if you know, in a triangle, if you draw a line parallel to the base, that gives you a similar triangle. So these two triangles are similar, okay, and since these two are parallel as well, these two triangles are similar as well. So we know that the main idea to solve this problem would require or involve similarity. Okay, now they're saying the height of the two unshaded portions are 11 and 5 as marked. They want us to find h. So straight up, we know that the main idea would be similarity, and we will use that to get an equation in terms of h, and if we can do that, we'll be able to solve it and find h. So basically, it's just a lot of algebra. So let's get right into it. So let's see. So we know that for similar triangles, this smaller one and this bigger one, ABC, we know their heights. So this is 11, right? And this is h. But what else can we compare it with? Well, I think one thing you can say common in both of these diagrams is the base. So let's take the base as, well, I don't know, let's say B, and then let's call this B as well. Then can we find this, the length of this base? Well, we can, because since these two triangles are similar, the ratios of the lengths must be the same. So we know, let's say this is B, and let's call this X. So we know that X over B should be equal to 11 over H. Again, I'm just using similarity. That tells me that X is equal to 11B over H. See, I'm getting everything in terms of B and H. So now that I have X in terms of B and H, I can find the area of the top triangle. What is that going to be? Well, that is going to be half. What is the base? Base is 11B over H times height. Height is 11. And what is the area of the big triangle ABC? Well, that's just going to be half base times height, right? And if you subtract these two areas, that is when you get this area. So let's see what that turns out to be. So we can just, first of all, simplify them. So we have BH over 2 minus, and then we have 121B, 121B over 2H. So that's the area. Can we combine it to be a single term? Well, we don't really have to at the moment, but let's just keep it like that. Now let's move on to the other side. So here, let me just draw the two triangles. This might be a bit more complicated. Let's see. So again, this is H and this is B. Then this is 5. If this is 5, then this is going to be 11 minus 5. Okay, and then to find the area of that inner triangle, so no, not 11 minus 5, sorry, that's H minus 5, yeah, okay. And then let's call this Y. So again, the ratio of these lengths has to be the equal. So let's see, we have Y over B equals H minus 5 over H. So that means Y equals H minus 5 times B over H. So what is the area of this shaded region? Well, that's just going to be half. What is the base? Base is Y, so H minus 5 times B over H times the height, which is H minus 5. Okay, so we know that these two are supposed to be equal. These two areas are supposed to be equal. So I'm going to write it down. That's going to be H minus 5 squared times B over 2h, and let me just make this have the denominator of 2h as well. So I'll multiply the top and the bottom by h, and I just end up having bh squared minus 121b over 2h, and since these two areas are equal, I can just set them to be equal to each other. Now I can just multiply both sides by 2h, and this will go away, I end up with bh squared minus 121b equals h minus 5 squared b. Now I can divide every single term by b as well, and that gives us h squared minus 121 equals h minus 5 squared. See, now we have one equation in just one variable, and that's great. So let's solve it. So let's open up the right side as well. So h minus 5 squared, well, that's just going to be h squared minus 10h plus 25, and here we have h squared minus 121. That is just the best because we can just cancel out the h squares, and now we have just a linear equation. So I'm gonna move the 10h to the other side. That's 10h, add 121 to both sides. So what does that give us? 121, 5, 6, 4, 146. Okay, so 10h equals 146, so then h is just 14.6, and that is our answer. So you see, this is just applying the conditions that they gave you, and just, you know, lots of algebra. So our answer is A. Okay, so in this problem we have 15 integers, and they are arranged in order on a number line, and they are equally spaced, and they have the property that, you know, a1 is in that range, a2 is in that range, and a15 is in that range, and so on. So they want us to find the sum of digits of a14, for which we will have to figure out what a14 is, and for that we'll have to, you know, first of all figure out what the sequence is. So the key thing to focus on is that they are equally spaced, and that is the thing that will help us crack this problem. So let's take a look. 15 integers. How many spaces do they have in between them? Well, they have 14 spaces, and let's say each space is you know, x units. Then you know, a1 plus x will give you a2. Right, so let me just write that here. So a1, a2, a3. So if the spaces are all x, so a1 plus x will give you a2, a1 plus 2x will give you a3, and so on. So that tells us that a1 plus 14x should give us a 15. Well, let's see, since you know, this problem depends on the multiples of 14, let's figure out what multiples of 14 do we have in the range of 240s to 250s. So let's see. So we know that 14 times 10 is 140, 14 times 5 is 70, so 14 times 15, well, that is just going to be 210. 14 times 16 is 224, 14 times 17 is just 238, 14 times 18 is going to be 252. Now, we know that x can't be 18 because even if we take the smallest value of a1, which is 1, and we add 252, well, that is out of range. We you know, a15 would be 253, and you know, that's out of range. So it can't be 18, so we can cross that out. It can't be 224 because, again, even if you take the highest value a1 can have, which is 10 plus 224, that gives us 234, and again, that's still not in the range of a15. So that means we know now that x is going to be 17, and that changes everything because now we know what the gaps are. So we can say that x is 17. We figured that out. Now how do we figure out what a1 is? Well, that's still very doable because let's take a look at this. If x is 17, let's figure out what is the smallest value a1 can have and what is the biggest value a1 can have. Okay, so if this is 230, oh, this is actually 238, then let's see, let's try to make the highest possible value of a15, which is 250. Well, to make that happen, a1 would have to be 12. Well, that's not possible, so that means the maximum possible a1 can be is 10 and still get in the range. Okay, And the minimum A1 can be, well, that's the more important one. To get to 241, it has to be 3. So that's the minimum for A1. Okay, that's the minimum. So let's try to use this information that A2 is between 13 and 20. So if we take the minimum value of A1, which is 3, then A2 would be A1 plus 14. Sorry, not 14, 17. So A1 plus 17, which is 20, and that's actually the maximum possible value of A2. So if we increase A1, right, so A2 equals A1 plus X. If the minimum possible value of A1 is 3, so that gives us 20 as the value of A2. But if we increase A1, let's say we take it to be 4, well, then A2 gets out of range. So now we know for sure that A1 is 3. So that, solves the problem, because now we know A14 is just going to be A1 plus 13x. Well, x is, so let's actually put that in. So x is 17, so 17 times 13, and then plus 3 would be A14. So let's do that here. So 21, 51, that's 7, and that's 1. So that's going to be 1. This is 2, so 221 plus 3 is 224, and then the sum of digits of 224 is 2 plus 2 plus 4, which is 8. So the answer is A. So guys, that's all for today. If you enjoyed the video, then press the like button and let me know in the comments below what you thought.